Okay, in problem number 4, we're talking about a piston, and it says to find the velocity of the piston when theta is equal to pi over 3. So a couple of things before we get started. First, we need to figure out what our given rate is. Our given rate, so d theta dt is our given rate because it's rotating, and we know it's rotating at a constant rate of 200 revolutions per minute. Remember that a complete revolution is 2 pi radians, but it's going 200 times per minute. So 200 times 2 pi would be 400 pi. So that's our d theta dt. That's our given rate. So 400 pi. Asking us to find the velocity of the piston. So similar to the last problem, we're finding dx dt when theta is equal to pi over 3. So we're going to have to use, because in this picture it blows up the triangle here, we have an angle and then two sides, and we're looking for this other side. We need to use the law of cosines because we don't have a right triangle. And the law of cosines says the side opposite the angle squared is equal to the sum of the two sides squared minus 2 times those two sides times the cosine of the angle between them. That is our formula for that we're going to be using, that we're going to be differentiating. Okay, so if I differentiate this, when you differentiate a constant, you get 0. So this would be 0, this would be 0, this would be 2x dx dt. And this would be minus 6. I'm going to take the constant out, and then I'm going to do my product rule. So the first times the derivative of the second. Derivative of cosine is negative sine. So I have negative, put the x first. So negative x and then sine theta d theta dt plus the second cosine theta times the derivative of the first, which is dx dt. If I were to go ahead and kind of make that look a little bit prettier, I end up with 0 equals 2x dx dt plus 6x sine theta d theta dt minus 6 cosine theta dx dt. So from here, if I just do some algebra, I want to get all of the dx dt terms on one side. So I'm going to move my two dx dt terms. So I end up with 6 cosine theta minus 2x times dx dt. And that's equal to 6x sine theta d theta dt. So again, I'm solving for dx dt, so dx dt then would be 6x sine theta over 6 cosine theta minus 2x times d theta dt. I'm going to actually go on to a new screen here just because I'm running out of room. Okay. So I had, let me just rewrite that. I had dx dt is equal to 6x sine theta over 6 cosine theta minus 2x times d theta dt. Okay, now before I can actually find dxdt, there's one other variable that I don't know. I don't know what x is, right? I already know what theta is, right? The theta that I'm going to use is pi over 3. I know d theta dt is 400 pi, but I don't know x yet. So I'm going to go back to this, and I'm going to solve this for x when theta is pi over 3. So if I go ahead and do that, so to find x, I've got 7 squared is equal to 3 squared plus x squared minus 2 times 3 times the cosine, times x. Let me rewrite that. Times x times the cosine of pi over 3. Okay, so we've got 49 is equal to 9 plus x squared minus 6x times 1/2, right? Cosine of pi over 3 is 1/2, so that would be minus 3x. So if I move the 49 over, I end up with x squared minus 3x minus 40 is 0. When you factor that, we get x is 8 and x is negative 5. We can't use our negative x value, right, because we're talking about a length. So we have to use x is 8. So now I can go back and substitute into my formula here. So I have 6 times 8 times the sine of pi over 3, which would be root 3 over 2. And then cosine of pi over 3 would be 1/2, so 6 times 1/2 minus 2 times x, or 2 times 8, which is 16, times d theta dt, which is 4, that looks like a minus sign there. And that would be 400 pi. I'll write down here. So that gives me then 9,600. If I multiply all my numerators together, I end up with 9,600 pi root 3 over negative 13, which you can leave it like that, but if you were to approximate it, it comes out to roughly negative 4,018 inches per minute. It said because the radius is in inches and our rate is in minutes, so it would be inches per minute. The velocity of the piston is negative. That means it's the speed, so it's slowing down basically. And that's how you'd go about doing that problem. So a quick recap, right? You're going to find the dxdt because we're finding the velocity. And so we take the derivative of the position. In this case, we're using x. So we're finding dxdt when theta is pi over 3. I had to use law of cosines for my equation. And then I have to use the law of cosines when theta is equal to pi over 3 to find x, so I can plug that back into my equation. That's basically how you go about doing that problem. Hopefully that helps. If you need to kind of watch that again to sort of make sense of it, please feel free. And I'll see you next time. Thanks!